And welcome back as we go ahead and dive into our next topic related to linked lists, which is that of iterators. So when we start looking at lists, a lot of times we're looking at how that data is being moved, how we're stepping through that list to find various different pieces of it. So for example, when we have a collection of objects such as the nodes of a linked list, you often need to step through the objects in the collection one at a time, perform some type of action on that object, such as either writing out to the screen, maybe you're editing the data, whether it's addition, subtraction, whatever you're doing with it. Well, an iterator is any object that allows us to step through the list in this way. So how do we actually go about implementing iterators? We can just kind of walk through these lists. Well, to do this, let's go ahead and look at this with an example. So we've gone ahead and rewritten linked list 2. So it has an inner class for iterators and a method called iterator that returns an iterator for its calling object. Now, we made the inner class of linked list 2 iterator public so we can have variables of type list2 iterator outside of the class linked list 2, but we do not otherwise plan to use the inner class list2 iterator outside the outer class linked list 2. So with those iterators, you'll note that given a linked list named list, an iterator for a list is produced by the method iterator as follows. So we could say linked list 2 dot list 2 iterator I list dot iterator. All right, because of course it's a inner class, so we have to follow this format. The iterator I, is produced in this way can only be used with the linked list that is named list. Now, you'll be sure to notice that outside of the class, the type name for the inner class iterator must include the name of the outer class as well as the inner class, and the class name for one of those iterators is linked list 2 dot list 2 iterator, and of course that is this part right here of our type. So let's actually get into the cycling of these elements, because that's ultimately our goal, right, is to get through these elements. Well, the basic method for cycling through the elements in the linked list using an iterator is illustrated as below. System out of the print line list now contains i.restart, while i.has next, system out of the print line i.next. The iterator in this case is I. The iterator I is reset to the beginning of the list with the method invocation i.restart, so every time you call it, you're doing i.restart, and the execution of i.next produces the next data item within that linked list. After all the data items in the nodes have been returned by i.next, the boolean i.hasNext becomes false, and the while loop is going to end. So this, of course, is, if you think about how this is working, is we're referencing nodes. Internally, the local variable position references the current node in the linked list, whereas the local variable previous references the node linking to the current node. Well, the purpose of the previous variable will be seen when you're adding and deleting nodes, because if we just say it's on ourselves, well, what does this mean? Well, if we start actually looking at this with some examples, it will make a little bit more sense. So in the constructor of the restart method, position is set to head and previous is set to null. So to determine if the end of the list has been reached, hasNext returns whether or not the position is null. So for example, return position does not equal null. So let's actually look at advancing that list then, shall we? So we're going to step through the list. The next method first throws an exception if we reach the end of the list. So if hasNext, or does not hasNext, we're going to throw a no such element exception, because rather than the list, there's no more elements. Otherwise, the method retrieves the string value of the iterator referenced by the position of the variable to return, advances the previous, which is our variable, to reference the current position, and advances position, which is our other variable, to the next node in the list, and returns the string. So string to return equals position.item, previous equals position, position equals position.link, and return to return. So when we start talking about this, there's one thing we have to keep in mind, which is the Java iterator interface. Now, there's actually an interface already built into Java called iterator that specifies how Java would like an iterator to behave. And it's part of the java.util package. Now, the thing is, if we look at these iterators, they're not quite going to satisfy this interface. They're not, a perfect match, but they're in the same general spirit as that interface and could easily be redefined to satisfy that interface's requirements. Now, because we're simply trying to learn how these iterators work and how to use them within our program, we're going to use this version that we're currently presenting before we go ahead and try to sink our teeth into anything much more. Because again, it's not much of a changeover for us to move to the specified version. So the first thing we want to talk about, of course, is adding or deleting nodes, because this is a great example for us to look at that's very simple. That'll help really zone in on how iterators work. So if we want to add or delete a node from a linked list, you normally would use an iterator to either add or delete a node at the location, approximately, of where that iterator is kept. Now, because deleting is a little bit easier for us to kind of work through, we'll discuss deletion first. So when we're deleting nodes, if you look at our flow chart here, you can see it has a couple nodes set up here in this list. And this would be a list that we could make with linked list 2. The variables position and previous are, of course, instance variables of an iterator for that linked list object. And these variables each hold a reference to a node indicated with an arrow. So you can see we have our head, our previous, and a position. Now, each time next is invoked, previous and position reference subsequent nodes in the list, and as indicated, the node at location is deleted by the following two lines of code. Previous.link equals position.link, position equals position.link. So if we look here, here's our existing node. So we have coat, oranges, shoes, socks. And so we're going to bypass with previous.link equals position.link. And what that's going to do is going to take this link here, because remember this link before was pointing to shoes. So we're going to take this link, and we're going to say, hey, we're now going to point it to here, to where socks was. Then we're updating position, because remember, position right now is not attached, right? It's pointing to this node, but this node's not part of the chain anymore. So we're going to change that to position equals position.link. And what that's going to do, it's going to take this pointer here and move it so that it points to socks. And because there's now nothing really pointing to shoes, Java is going to recycle the memory that's been allocated for it, effectively removing it out of that list, so no more shoes. And so then we get coat, orange shoes, socks. So when we talk about that deletion, all right, one thing you'll notice is that next has actually been invoked twice. So the position variable is referencing the node shoes, and the previous is referencing the node socks. And as we talked through that, we said, we want to delete that. The link from the previous node is set to the positions link, and as shown, it removes that reference. So the variable position, of course, is obviously as we saw, was set to the next node to remove any references to that deleted node. Now, there are special cases that, of course, we do have to handle for deletion. First off, if the list is empty, well, then nothing can be deleted because, well, there's nothing list, so it's going to throw an exception. Secondly, if the node to be deleted is the head of the list, well, there's technically no previous node to update. Instead, the head is set to head.link to bypass the first node list, and we'll set a new head node. And as we mentioned previously, garbage collection is going to happen. As far as the linked list is concerned, the old node is no longer on the list. When we took shoes out of there, it's not part of that list. But as we said, it's still in memory. And because it's still in memory, well, because there's nothing for it to be used, no references or anything like that, but that storage of memory is still taking place. So we need to clean that up. So in many programming languages, we may have to keep track of what to do with that memory resource. Keep track of the deleted nodes. You have to give an explicit command to return that memory for recycling. However, that automatic processing is done for us in Java through garbage collection. So we don't have to actually do any calls to say, hey, there's this node floating out here, but it's not tied to anything. Can you get rid of it? Java does it all for us automatically. Now, let's look at the same thing, but with adding nodes. All right, so when we start talking about adding nodes, all right, we're going to see, of course, it's going between previous and position, again, like we had before. All right, but you'll notice that now we have a new node that's going to go between the previous and positions. The method next, of course, is being invoked twice, advance previous to orange shoes and position shoes. So if we look at our flow chart, we'll see we had our three nodes to start with. We have code, orange juice, and shoes. And then we're going to say, hey, we're going to create a new node with socks. So that was, of course, the one we deleted, but we're creating a new one. And we're going to link that back to shoes. And what we want to do is make previous link. And we're going to set to the node temp. So this is now going to point here. So instead of orange shoes pointing to shoes, it's now going to point to socks. And remember, even though this is now pointed here, it's effectively just moved right here. So this picture right here is, of course, structurally the same thing as here. Only difference is that we've now updated all these points to go ahead and show in here. Now, temp, of course, is just a temporary marker in here, so it doesn't really matter what it is because that's only to insert that singular point. So the constructors to create new, are actually going to be really nice because it's going to do a lot of the work for us. So it's going to create the new node, it's going to add the data, set the link field of the new node to reference the node named by position, and it's all done with just saying new node, new data, comma, position. And we can recognize the node with new data in when we set the previous displays. When we look at that example, we can see how easy that was for it's like, oh, it's just updating these references where these things are going. So we're going to assume that new data is going to hold that string socks in that example. And of course, if we want to get us into from that first step to that second step, we would say that with the code line temp equals new node, new data, comma, position. Now with those nodes, obviously that's one thing, but we just need to update that link, right? We got to go from the previous node to the new node, and we're going to do that by moving the arrow to that node named temp, which of course is going to finish our job. So we have previous.link equals temp. This new node is then inserted into the desired place. But if you're not, it's like you're like, this diagram's a little confusing. How do we do that? Of course, that there could be some confusion between the third and fourth step. Don't worry about they're the exact same thing here. Because ultimately what we're doing is we're putting new data in, right? So that's what we're trying to do. So if we want to put this new data into a linked list, the following two lines insert a new node as the data. So all we really know is this. So we're going to insert it with the code temp equals new node, new data, comma, position, previous link equals temp, and that updates it. Previous, position, temp, of course, are all variables of type node, and when we use this code, previous and position will be instance variables of an iterator, whereas temp will be a local variable. And just like with deletion, there are special cases for insertion that have to be handled. For example, if the list is empty, well, addition is done by simply just adding to the front of the list. Now, if the position variable is null, well, then the new node should then be added to the end of the list. And if we go ahead and look in Eclipse, we can see here we have a quick linked list 2 being created here. So this is our revamped linked list 2. But in this demo, we can see we're adding some items to our list. And it's going to say list.contains, and it's calling the restart here. So we can see right here's our i.restart, which gives us that nice refresh. And then here's our while loop that's going to then step through each of those items here. So it's going to simply call out i.hasNext, and it's going to system out println i.hasNext, and so i.next until it reaches no more items within list. And then it's going to restart, which allows us to remove that, remember, position back to the start of the list, because we don't want to have that floating out at the end of the linked list. So we're going to move the iterator back to the beginning. And you might say, well, why did we put it here? It's just a good idea to have that there because it ensures with the i.restart that iterator, for whatever reason, if it's some reason it's not at the start of the list, it will make sure that it is forced to the start of the list. So let's just add that quick comment. So this is places iterator at the start of the list. Good quick reminder there for us. And of course, anytime we restart, that's what that's doing. This is, of course, going to delete out that node and then reprint it for us. And this, of course, is going to add that node and then print it for us. And then, of course, this is going to give us some nice information here. So let's go ahead and run this. So we have list contains, and we have coat. We have orange juice, shoes, and it's going to delete the node for orange juice. So now we just have coat and shoes, and then it's going to add one in. So coat, socks, and shoes, and then it's going to change all items to charging all items credit card, and it says list now contains coat, socks, shoes. So again, a quick way for you to see how this works here. All right. And so this says i.restart, this is i.next, i.change here, credit card, i.next, and of course the list now contains. So again, a great way for us to look through how this program is working with the step through with iteration.